A surreal, long-standing fact in astrophysics that continues to endure well into the 21st century is that the great majority of study in the field is devoted to objects and entities whose existence has never been directly proved. Even more surreal is the overabundance of direct proof that challenges, disconfirms, or outright falsifies the existence of said objects and entities, yet with no apparent impact on the theoretical models and path of exploration in the space sciences. The final layer of surrealism is that plausible, empirically supported alternatives do exist to these unproven chimeras, and yet remain totally ignored in academia and institutionalized science. Perhaps nowhere is this disconnect between observational data and astrophysical theory more evident than in the scientific study of pulsars, a periodic electromagnetic signal which astrophysicists attribute to a hypothetical object called a neutron star mechanically spinning like a lighthouse. Neutron stars were first proposed nearly a century ago, and when pulsars were discovered in the 1960s, Thomas Gold argued that a rapidly rotating neutron star was the most likely source. However, the assumption that neutron stars actually exist is fraught with very serious theoretical and experimental objections. This is summarized succinctly by Dr. Donald Scott in the following statement. The neutron star is simply yet another fantasy conjured up, this time in order to avoid confronting the idea that pulsar discharges are electrical phenomena. A nucleus or charge-free atom made up of only neutrons has never been synthesized in any laboratory, nor can it ever be. In fact, a web search on the word neutronium will produce only references to a computer game, not to any real scientific discussion or description. Lone neutrons decay into proton-electron pairs in less than 14 minutes. Atom-like collections of two or more neutrons will fly apart almost instantaneously. In my opinion, it can't be overstated what an extraordinary claim the neutron star's existence is, and always has been. Consider this description on an official NASA webpage. Matter within a neutron star is so dense, a teaspoonful would weigh about 1 billion tons on Earth. It therefore should not be surprising when we see science reports of neutron stars behaving in ways that defy logic, reason, their own theoretical framework, and sometimes even the laws of physics. In the past, this has included so-called neutron stars shining with the apparent brightness of up to millions of suns, thus appearing to shatter the Eddington limit. Pulsars have also been discovered whose periodicity is so rapid, it would require a rotating neutron star to spin at up to 1/4 the speed of light. Another type of hypothesized neutron star is called a magnetar, which are characterized as very young neutron stars passing through a phase of possessing an almost supernaturally powerful magnetic field. Now keep in mind that a hypothetical neutron star is said to typically be about 20 kilometers in diameter, and the magnetic field of a magnetar is said to be about 1 quadrillion times more powerful than the magnetic field of the Earth. Now one particular so-called magnetar has been puzzling space scientists for over 2 decades. In 2003, a magnetar, whose name you see on your screen, was discovered emitting radio waves in a chaotic way that didn't match any astrophysical model. Then in 2008, it appeared to suddenly stop. A decade later, its weird emissions were detected again, except this time, they are both, quote, twisted in an inexplicable way, and they appear to indicate that the star is mechanically wobbling. In a recent Science Alert report, the respective lead authors of 2 separate papers comment on the discovery. Astrophysicist Markus Lowerer states, "Unlike the radio signals we've seen from other magnetars, this one is emitting enormous amounts of rapidly changing circular polarization. We had never seen anything like this before." Likewise, investigator Gregory Disvines from the Max Planck Institute for Radio Astronomy says, "We expected to see some variations in the polarization of this magnetar's emission, as we knew this from other magnetars. But we did not expect that these variations are so systematic, following exactly the behavior that would be caused by the wobbling of the star." The next statement from the aforementioned Markus Lowerer will surely pique the interest of the electric universe and plasma cosmology communities. Quote, "Our results suggest there is a superheated plasma above the magnetar's magnetic pole, which is acting like a polarizing filter. How exactly the plasma is doing this is still to be determined. However, as the report continues, we gain further insight into the depth of the obstacles astrophysicists face when attempting to resolve the intractable problems to which the consensus theory has inevitably led. Quote, Disfines and his team found that the polarization revealed a shift in the magnetar's orientation with respect to Earth. In other words, it seemed to be wobbling, or precessing, like a spinning top. But this got surprising too. Over the next few months, the precession damped significantly and eventually stopped entirely. Now, from my perspective, both the latter and former remarks reveal the crux of the obstruction to meaningful progress in the theoretical space sciences. If the data suggests, as Markus Loweër states, that the observed emissions are caused by a, quote, superheated plasma above the magnetar's magnetic pole, then it would make sense to look for an answer in the realm of plasma physics. And as longtime viewers of this channel have known for many years, plasma cosmology and the electric universe do offer an explanation for pulsars and so-called magnetars, which do not include an incredible neutron star mechanically spinning like a lighthouse. As noted here many times previously, in 1995, Drs. Anthony Peratt and Kevin Healy authored the scientific paper Radiation Properties of Pulsar Magnetospheres, in which they examined roughly 12.5 unresolved pulsar anomalies unexplained by standard theory. In effect, Peratt and Healy proposed that an electrical discharge occurs close to a star, which then travels along magnetic field lines outwards, where it encounters a disk of matter surrounding the star. Where it meets that more dense matter, a kind of short circuit occurs, and the signal is reflected, as in transmission lines in electrical engineering theory. In the Peratt-Healy thesis, the mechanism causing a pulsar's stable periodicity is observed on Earth in the form of the most stable oscillator ever achieved, called an ion trap. In other words, an experimentally supported, peer-reviewed explanation for pulsars does exist, which does not require a fantastical neutron star. I'll again refer viewers to the statement of investigator Markus Loweër. Our results suggest there is a superheated plasma above the magnetar's magnetic pole, which is acting like a polarizing filter. How exactly the plasma is doing this is still to be determined. Now, I have to state the obvious here. The extreme magnetism of a so-called magnetar is the absolute clearest requirement that electric currents are driving the observed phenomena. I have to admit, it's at times like this that I especially miss our friend Wal Thornhill, with whom I could discuss these matters at great length and detail. I'd like to acknowledge a couple of things. Number one, within the larger EU community, and particularly the tight inner circle of scientists in the Thunderbolts community, I've met more than one electrical engineer who has confessed that he's not yet found an explanation for pulsars that he finds completely satisfactory, particularly because of the extreme stability of a normal pulsar's periodicity. And in the case of the mystifying magnetar we're discussing here, including the fact that it appeared to simply turn off for about a decade, I can't claim to know that Peratt and Healy's explanation, or any offered by the chief principals of the EU and the Thunderbolts project, can completely explain all of the details. That is the reason why, when I discuss electric universe theory in these reports, I always use 3 words to convey the invitation our community is offering to the scientific world. Promising theoretical pathways. Is the source of a pulsar an electrical oscillation in a very powerful, dynamic plasma environment? Or is the source an unimaginably dense, dead star that is mechanically spinning at an unfathomable speed? As a layperson who has looked as closely and carefully as I can at these issues for the last quarter century or so, my humble thought is that nature and the larger cosmos is not nearly as strange as mainstream space science seems to suggest. When it comes to the ongoing intractable mystification that astrophysicists and astronomers keep encountering, I really do think it boils down to the state of the educational system and the unwavering focus of institutionalized science on gravity-centric theory in physics and cosmology. In my opinion, it's not ultimately a question of space scientists being, quote, close-minded as such, or unethical or unintelligent. They understandably look for answers in the foundation of their own specialized training, and through consultation of the available literature in their chosen field. Promising theoretical pathways, such as those offered by the electric universe and plasma cosmology, do not require the official sanction or support of powerful institutions in order to move forward. Those who have joined in our community have certainly learned patience, and it's our privilege to continue to explore and discuss these matters together, in the hopeful certainty that others in increasing number and with growing strength and fortitude will join us in the adventure.